Hey guys, hello and welcome. As you see, we are going to discuss these topics in this chapter, and after one by one we will discuss more topics. Like as you see, this is the unit 1 and we will make the video. This is actually an audiobook. You hear it. So what the basic idea is here, just we are going to go through all the chapters and the books and whatever is written in the book. So and we will try to understand and through this book. So this is the unit 1, the solid state, and we have to study those things like general characteristics of solid state, amorphous and crystalline solids, classification of crystalline solids, and crystal lattice and unit cells, number of atoms in a unit cells, and close packing structures. So we will discuss what is this and what are those things and how to understand. We will discuss many things here. So packing efficiency, then calculations involving unit cells and dimension, then imperfections, and then electrical properties and magnetical properties of a solid state. So many things is here to discuss, and we will talk on that. So our main motto, or you can say our objective here to study this chapter. So what we will get if we study this chapter. So after studying this unit or chapter, you will able to describe general characteristics of a solid state, distinguish between amorphous and crystalline solids, then classify on the basis of nature of binding force, define crystals, lattice and unit cells, and explain close packing of particles, describing different type of voids and close packing structure, calculate the packing efficiency of a different type of cubic unit cells, correlate the density of a substance with its unit cells, then describe the imperfections in a solid and their effects on properties, and you can correlate the electrical and magnetic properties of a solid state and in the structure. So we came here, we will talk about the solid state. The vast majority of a solid substance like high temperature, superconductor or biocompatible plastics, silicon chips, etc. are destined to play an ever expanding role in future developments of science. So we are mostly surrounded by solids, and we use them more often than liquids and gases. More different applications, we need solids with wide different properties. Those properties depends upon the nature of constituent particles and the binding force operating between them. So therefore, study of a structure of a solid is important. The correlations between structure and properties help in discovering new solids material with desired properties like high temperature, superconductors, magnetic materials, biodegradable polymers for packaging, or biocompliant solids for surgical applicants, etc. So from our earlier studies, we know that liquid and gases are called fluids because of their availability to flow, but solid can't flow. We will see how it can flow it. So the fluidity in both of those states is due to the fact that the molecules are free to move about. On the contrary, the constituent particles in solid have fixed positions and only oscillated about their mean positions. This explains the rigidity in solids. In crystalline solids, the constituent particles are arranged in a regular pattern. In this unit, we shall discuss different possibilities, arrangement of particles resulting in several types of structures, and correlations between the natures of interactions with the constituent particles and several properties of solids. And will also be explored how those properties get modified due to the structural modification, imperfections by the presence of impurities in minute around would also be discussed. Now let's talk about the general characteristics of a solid state. In your class 12, in your class 11, you have learned that matter can exist in the 3 states, namely the solid, liquid and gas. So there are 3 states of matters, but there are also another state of matters we have. But nowadays we consider that mostly 3 state of matter: solid, liquid and gas. Under given state of conditions of temperature and pressure, it's important to mention this, like under given set of temperature and pressure. So because of temperature and pressures can change the state of matters. So which of those would be the most stable state of a given substance depends upon the net effect of 2 opposing factors intermolecular force tend to keep the molecules or atoms or ions closer. So where the thermal energy tend to keep them apart by making them move fast at sufficiently low temperatures. The thermal energy is low and intermolecular force bring them so close that they cling to one another and occupy fixed positions. So those can still oscillate about their main positions and the substance exists in solid state. The following are the characteristics. So let's talk. Let me give you 5 characteristics. There's mentioned 5 characteristics. So the first one is they have different mass. What I'm talking with you the characteristics of a solid state. They have a different mass, volume, and shapes. You see, different solid. Like is solid like iron, or solid like any material. Right? You see, you can hold it. Whatever the solid state, whatever the solid material, it have the definite mass, volume, and shapes. The number 2 is the molecular distance are short. If you see in a microscope, a very high, zoom. In a molecular level, we have to see, but it is not very possible. So you need more powerful microscope. So in an intermolecular distance are very short. They are get very close to each other. Their constituent particles, atoms, molecules, and ions have fixed positions and can only oscillate about their mean positions. And they are incompromisable and rigid. Now let's talk about the amorphous and crystalline solid. So now let's discuss. Solid can be classified as a crystalline or amorphous on the basis of the of order present in the arrangements of their constituent particles. A crystalline solids usually consist of a large number of small crystals, and each of them having a definite characteristics, geometrical shapes. In a crystal, the arrangement of a constituent particles, atoms, molecules, or iron is order. It has a long range order, which means that there is a regular patterns of arrangements of particles which repeated itself periodically over the entire crystal. Keep it in your mind. Solids, chloride, sodium chloride, and quartz are typically examples of crystalline solids. So an amorphous solids, actually amorphous is a Greek word. So in Greek, amorphous, it means form. So consist of a particles, an amorphous solids consist of a particles of irregular shapes. The arrangements of a constituent particles in such a solid have only short range order. In such an arrangement, a regular and periodically repeating pattern is observed over short distance only. Such portions are scattered and in between the arrangement in disorder. The structure of a quartz crystalline and a quartz glass amorphous are you can see here. Like this is the the two-dimensional structure of a quartz, first one, and the second one is a quartz glass. And you can see and notice the different in structure. Now, while the two structures are almost identical, yet in the case of amorphous quartz glass, there is no long range order. The structure of amorphous solid is similar to that of liquid glass. Rubber and plastics are typically example of amorphous solids. So due to difference in the arrangement of the constituent particles in the two types of solids in their properties. Anisotropic in nature, that is, some of their physical properties like electrical resistance or reflective index show different values when measured along different directions in the same crystal. This arises from different arrangements of particles in different directions. This is illustrated in, you can see this figure. So this is a figure of anisotropic in crystals is due to the different arrangement of particles along different directions. You see? Now let's come to the point. Now, since the arrangement of a particle is different along different directions, the value of the same physical properties is found to be different along each directions. So amorphous solids, on the other hand, are isotropics in nature. It is because there is no long range order in them and the arrangement is irregular along all the directions. Therefore, values of physical properties would be same along any directions. Those differences are, you can see here in this box. So let's talk about in the box what is there. So guys, what is in the box? First is the shapes. What is the shapes? The definite characteristics geometrical shapes. The shapes, if you compare the shapes of a crystalline solids and amorphous solids, so this is the differences here given. So the shape is different. That if we talk about the shapes, so definite characteristics geometrical shapes for crystalline solids. But in amorphous, you can see regular shapes. Melting point, melt at a shapes and characteristics temperature. But in amorphous solids, gradually soften over a range of temperature. In a crystalline solid, the cleavage property, when cut with a shapes edge tool, they split in two pieces and the newly generated surface area are plain and smoother. But in amorphous solid, when cut with a shapes with a sharp edge tool like knife or anything, a very sharp knife, they cut into two pieces with irregular surface. So this is the difference. And now talk about heat of fusion. So they have definite and characteristics heat fusions. The crystalline solids have a definite and characteristics heat of fusion, but of amorphous they do not have definite heat of fusion. Anisotropy in case of crystalline solids, anisotropic in nature, but amorphous are isotropic in nature. In their nature is they are true solids, a crystalline, and amorphous are pseudo solids or supercooled liquid. Long range order in arrangement, they are in long range order. Order in arrangements of constituent particle, but in amorphous only short range order. So guys, this is all about in this part, and we will talk more on another part. So I hope you like this video and keep watching, and follow us on our Facebook page and here Twitter and YouTube. So if you are first time, just subscribe and share this your friends and the students they need. So hopefully, thanks for watching and keep watching.